Assalamualaikum and greetings to everyone. I will present our research entitled Selection of Meteorological Rain-Based Drought Indices and Trend Analysis using CHIRPS Satellite Precipitation Product in Johor River Basin, Malaysia. Drought is complicated by the fact that it is difficult to predict impacts. Large area slowly develops and its presence is normally only detected after weeks or months. Although there is no universal definition for drought, drought can generally be defined by lower levels of rainfall than what is considered normal rainfall in a given climatic zone. Within this context, in a tropical humid environment such as Malaysia, where precipitation is normally evenly distributed throughout the year, a drier than normal period of several weeks or months may constitute a drought. Droughts are commonly classed as meteorological, agricultural, hydrological, ecological, and socio-economic. Considering the regional context of the drought, a number of drought indices have been developed. Because none of the approaches now in use can be deemed universal, emphasis should be given to the right selection of drought indices. However, relatively few papers on drought identification and characterization has been published across Peninsula Malaysia. This spurred the need for drought assessment in the Johor River Basin, located in the southern region of Peninsula Malaysia, where agriculture is a major economic sector and where serious drought-related damage have been reported in recent years. Besides, highly valuable ecosystems are situated along the Johor River Basin, and their survival is highly dependent on the amount of rainfall and natural flooding frequency. Therefore, the impact of drought on this environment should be considered. In this study, 7 rain-based meteorological drought indices, namely RAI, SPI, CZI, MCZI, PN, DI, and ZSI, are used to evaluate the meteorological droughts in Johor River Basin, which face increasing water scarcity issue in recent years. This research finds it novelty in terms of its relevance to simulate drought occurrence and robust methodology to select the best drought indices to be used over a basin scale in the case of Johor River Basin. Johor River Basin span extensive spatial domain of complex terrain with a high variation of rainfall climatology. Based on the CHIRPS dataset, the average annual rainfall for the period of 1981 to 2020 in Johor River Basin is 2,515 mm, with the highest total of 3,122 recorded in 2007 and the lowest total of 1,890 mm recorded in 1997. 73%, which is 79 grid point of the area in Johor River Basin, show significant changes in the annual number of rainy days by using a month candle test at 95% confidence levels. There is a difficulty in basin scale study in Johor River Basin due to insufficient observational data and inconsistency between different observed datasets. Okay, such limitation makes partially and temporarily constant yet fine resolution graded climate data more appropriate. Therefore, 109 grid point of graded best CHIRPS rainfall dataset of desirable period spanning 40 years from 1981 to 2020 across Johor River Basin was used for drought analysis. Besides, CHIRPS dataset also provide a good spatial resolution of 0.05 degree to sufficiently monitor drought condition over the basin. The procedure used for drought analysis are as follows. First, initially, the threshold and classification for each meteorological drought indices were defined and adjusted with a range as shown in this table 1, so that we can make a suitable comparison. Then, the intercomparison of the study meteorological indices was assessed based on their Pearson correlation coefficient by constructing a heat map based on the correlation plot to determine the consistency between the different methods in determining meteorological drought condition under various timescales. A scatter plot was then constructed to inspect the linearity relationship in capturing the dry condition. The low performance meteorological drought indices will be discarded for further analysis. Then the spatial mapping of the selected meteorological drought indices will be prepared. The best meteorological drought indices capable of detecting various drought conditions and drought frequency will be selected. Finally, mapping based on the based on the best selected drought indices will be done to determine the spatio-temporal trend of drought in Johor River Basin. The figure here shows that a good capability of the CHIRPS dataset in simulating the local climate in Johor River Basin. It was found that the correlation between all drought indices for all stations show a high correlation under different timescale, more than 0.69. It was found that the correlation of RAI, PN, and DI with other indices show a comparatively lower correlation for the 1 to 9 month timescale. Therefore, RAI, PN, and DI will not apply for the subsequent analysis. Figure here show that the scatter plot for the selected grid points show the linear and positive relationship for a combination of drought indices of CZI, MCZI, SPI, and ZSI. A good linearity was found for all cases with a square ranging from 0.961 to 0.995. Then the spatial map of drought frequency under 3 and 6 month timescale were constructed to spatially assess the performance between CZI, MCZI, SPI, and ZSI in determining the presence of drought. High drought frequency of moderately dry condition was observed throughout the basin under a 3-month timescale. However, under very dry condition, drought frequency was mainly observed at the downstream and east of the basin, with better detection by CZI and SPI. Under 6-month timescale, moderately dry conditions were observed at the downstream area, with better widespread detection by CZI and SPI. Comparatively, SPI show a better performance than CZI in spatially detecting the presence of drought in the form of drought frequency in Johor River Basin. Therefore, SPI was selected as the best drought indices for drought assessment in Johor River Basin. Trend assessment based on the month candle test at 95% significant level show that the drought condition is significantly decreasing in the downstream of Johor River Basin. The decreasing drought condition owing to the significantly increasing number of rainy days throughout Johor River Basin, as rainy days has become more sporadic and unpredictable due to climate change. The uses of a gridded-based rainfall CHIRPS dataset provide an opportunity for a better spatio-temporal assessment of meteorological drought for basin scale study. The result of this study can be used for comparative study with other river basins in Malaysia to improve our understanding of the prevalent drought occurrence and its impact across the different areas. Thank you.